The quiz problem for today was to take this data, this y versus x data, and determine which of the proportionalities y equals kx squared, y equals k to the x to the 1.5, or y equals kx to the 2.5 is most appropriate. We can begin by examining the one in the middle, the kx squared. Okay? So we find the k value for a y equals kx squared model here, abbreviating that k for kx squared. And if we use the first data point, x equals 1, y equals 5, we put 1 in for x, 5 in for y, we obtain k value 5. If we put 2 in for x and 28 in for y, we obtain a k value of approximately 7. Actually, it's exactly 7. If we put 80 in for y and 3 in for x and solve for k, we get approximately 9. And if we put this data point in, we get approximately 10. Actually get exactly 10 in this case. And we see that k doesn't come out anywhere near the same for any two of these, and that there's certainly a progression in the k values. If they were just randomly fluctuating and not varying by that much, we might say, well, yeah, the data is pretty much a kx squared set of data. But with this increasing progression here, we're certainly not going to conclude that we have a kx squared proportionality. Now, if we do the same thing for kx to the 2.5, the value of k for kx to the 2.5, every time that we put one of these data points over here into kx to the 2.5, we're going to get 5, or something very close to 5. That is, put x equals 1 in, y equals 5, obviously k is going to equal 5. You put x equal 2, raise it to the 2.5, and put y equals 28, and then divide to get k. You again get something very close to 5, so that we get 5s for every data point. 5 or something very close to it, and this pretty conclusively shows that this is the right function. We could also go ahead and do the y equals kx to the 1.5, and many people did, because of course there's no reason to expect one as opposed to the other in this case, and it'd be perfectly reasonable to do that, but it's going to turn out that that also has an upward progression. It's even faster than the upward progression of the kx squared. Okay, so that one's not going to work at all. So we draw the conclusion, again, that not only is this the best of the three, but it really is pretty good.